So we are starting a three-part series on function transformations. This is part one. And our goal in part one is to understand the graphs of what I call parent functions, mother functions, or basic functions. Because what we'll be doing is we'll be using these basic functions to then apply transformations and be able to graph them based on the basic function and the transformations given. Okay, so the first type of function that we'll go over is called the quadratic function. This comes in the form of f of x equals x squared, and I have the graph of it here. So it's a parabola, and these values, these ordered pairs that I got, you can use a table of values. For instance, if you plug in x equals -2 into x squared, f of x would be equal to 4, and so on and so forth. So I have these points outlined here for you on the graph just to help you. Maybe if you don't know what a parabola looks like, you can always do a table of values and make the graph that way. Next is the cubic function. This comes in the form of f of x equals x cubed. And so we've got a few points, -2, -8, because if we take -2 to the third power, this means -2 times -2 times -2, which is -8. Okay, we have -1, 1, 0, 0, 1, 1, and 2, 8. Okay, and it forms this path. So this is the graph of a cubic function. And again, I've written out a table of values here as well. Next is the square root function. Okay, so it starts at 0, 0. Remember, we can't take the square root of a negative. So really the domain for this function, and you can see it from the graph, is 0 to infinity. Okay, and the range is also 0 to infinity. Okay, so we have 0, 0, 1, 1, 4, 2. Okay, so if our x value is 4, we take the square root of 4 and we get 2. Okay, you could also do 9, 3. X values in this case, I would pick x values that are perfect squares so that when you take the square root, we get a whole number as an output. The next function is the cube root function. So this is the cube root of x. Okay, so when we take the cube root of a number, let's say we're taking the cube root of 27. We're looking for a number that multiplies to itself 3 times to get this number. So this would be 3 times 3 times 3. Or for instance, if we plug in 8, cube root of 8 is 2, and that's because 2 times 2 times 2 times 2 is 8. Okay, so I have a table of values here. Again, and notice with the cube root, we are allowed to take the cube root of a negative number. And that is because if we had the cube root of -8, it's -2. That's because -2 times -2 times -2 is -8. Okay, so this graph does allow for this function does allow for negative x values. The next function is the absolute value function. So we did talk about absolute value back in unit 1. In terms of the table of values, if we put -x or -2 in for x, absolute value of -2 is 2. X is -1, absolute value of -1 is 1, and so on and so forth. So this graph forms a V, okay, or the shape of this graph is a V. Next is our rational function. So this is our parent function of rational functions. It's given as f of x is equal to 1 over x. So if we plug in -2 for x, we would get -1/2. If we plug in -1, we get -1. Notice we can't plug in 0 because we can't divide by 0. Look what happens in the graph. We just get closer and closer to x is 0, but we never actually get there. Okay, and these other values you can plug in as well. So we've got 2 pieces here to this graph of a rational function. Thank you for watching. I highly recommend you put these in your notes with some of the identifying points because it will greatly help you when we go to our next lesson about applying transformations.